Formula One is the pinnacle of motorsport. The fastest circuit racing cars in the world. Over 700 horsepower. Weight refined to the last gram. Every part built meticulously and exclusively. This is engineering at its very peak. Now, elite Formula One team Williams F1 are opening the doors to National Geographic for unprecedented access to their state-of-the-art mega factory at the most important moment in their illustrious history. High technology and individual brilliance must come together as the Williams mega factory embarks on a race against time to build a winning car for the now and keep the track dream alive for the future. The FW33 Williams Formula One car. The most advanced type of car in the world. Millions of dollars of pure racing. Searing power. 0 to 100 in just over 2.3 seconds. 320 kilometers per hour to a standstill in less than 3. A tuned, sculpted masterpiece of automotive engineering.
The Formula One is not only a car, you know, it's something more than a car.
Williams F1 are a thoroughbred racing team with well over 100 race wins.
We have a fantastic heritage in Formula One. We've been competing for more than 3 decades, and we are one of the largest and most successful teams in the history of the sport.
A company like Williams is a living entity trying to run as hard as it can and make as much progress as it can to develop competitive advantage.
Formula One's racing calendar produces a uniquely pressurized environment. Williams have a dedicated workforce of over 500 people. Here, at the Williams Mega Factory, as they probe and push the limits of speed, innovative engineering and specialized production turn over in a relentless cycle. The Williams F1 car is in constant evolution. Dawn at the Williams HQ in Oxfordshire, England. The team trucks arrived back from the last race in Italy. They've driven 9 hours through the night to make it back. Inside are 2 Formula One cars in pieces. It's Tuesday morning. As the sun rises, the Williams team starts to unload. This is race bay. In less than 4 days, the cars will have to be totally rebuilt here, ready to be shipped to the next sector of the season, a 2-month stint in the Pacific Rim and Middle East. The team know they have to be done by Friday night, or the trucks will miss their flight. It's a non-negotiable deadline,
We only got back in today, Tuesday. All the servicing of all the parts and all the cars has got to be done before we need to be packed away Friday morning. Yeah, it's quite pressure. There's a lot to do. People are rushing around, you know.
In Formula One, the factory runs 24/7. Williams never sleeps. Tim Newton is Williams F1's production general manager. It's his job to make sure that every element of the factory works in unison around the clock.
There's a lot of work that goes on in a sort of constant nature, and this really means that there's 24-hour working in all areas, and this creates sort of an invisible wave of work. This army of people that work, you have to make sure that they've got all the equipment they need to be able to do the job.
The race to get the cars ready has begun.
Whatever happens, you know, we'll be working for as long as it takes to get the job done.
While the team feel the pressure on the factory floor, Williams F1's management are squaring up to a major challenge of their own.
I think in recent years, corporate sponsorship has become much more difficult, which is partly due to the commercial instability that's been present in the world since 2007, 2008.
Williams are a well-established team, but competing at the top of Formula One is expensive. Some of their rivals spend up to $320 million a year. In recent times, Williams have battled to get on the podium.
I suppose over the last decade or so, we've seen that the cost to compete in Formula One went up significantly, and that made it very difficult for mid-sized teams like Williams to be fully competitive.
Williams F1 want to get back to the front of the grid. But to fund their push for the top, the board need to expand the business outside of racing. Williams know their greatest strength is their engineering expertise. Formula One paved the way for carbon fibre in high-performance road cars. And the team believe there must be other commercial opportunities for F1 engineering.
We work right at the leading edge of technology all of the time, and I really enjoy the fact that we can take technologies from Formula One and apply them to some of the challenges that we see elsewhere in the world.
Armed with the knowledge that fresh income could be key to success on the track, Williams begin the search for an engineering idea they could sell to a wider market. The team have never taken their technology beyond racing before. It's a journey into the unknown. In Race Bay, the team are at full speed. The rebuild starts with the chassis. It's the central piece all the other parts of the car are built out from.
The chassis is the backbone of the car. It is the most important part of it. It holds everything else together.
It also houses the driver. Motorsport is notoriously dangerous. There have been many hundreds of spectacular high-speed crashes. Moving at 290 kilometers per hour, a driver can be put through more than 50 G on impact. In 1994, Formula One legend Ayrton Senna was killed when his car smashed into a barrier. Another young driver died at the same Grand Prix. After that weekend, safety became paramount. The modern Formula One chassis, or cockpit, is 60 sheets of carbon fibre deep. The outside layer is bulletproof Xylon, protecting the driver against flying debris. Known as the survival cell, the cockpit is by far the thickest, strongest part of the car. In 2011, IndyCar driver Dan Wheldon was killed in a high-speed crash. But no Formula One driver has died since Senna. Unlike the super-strong chassis, most parts on the F1 car don't last. Tearing around a track, screaming towards top speed, and crunching deceleration under braking, the mechanical strain of Formula One is brutal. To stay ahead of the game and guarantee all the parts on the race car are fresh, Williams give each piece a predefined lifespan. That life is measured in kilometres. As it travels with the car on track, it clocks up distance. The team know exactly when its life is up. Before the end of this week, several hundred parts need to be replaced.
A lot of the parts on the car have got a designed life. They've got a certain amount of time that you know they're going to last, and these parts are replaced on a regular basis.
In Race Bay, the team have unloaded a gear change manifold. It's past its lifespan and needs to be replaced.
This particular part is now out of its life, and Derek's showing us on the screen here it's done 11,500 kilometres. So this part, it's got to be completely replaced. It's actually out of its usable life.
The parts in Formula One are specialised and unique. Each cog and screw will be engineered the Williams way. The Williams mega factory needs to make many parts themselves. At the heart of the factory lies the machine shop. Inside this room, there are 23 automated robotic lathes. The robotic lathe can follow technical 3D plans and perfectly replicate any part.
So, this is the part we saw earlier. It's out of miles, needs to be replaced. So, we come into the machine shop. Here's a large block of aluminium, ready to make the new one. This will go onto the machine, and it will run for approximately 28 hours non-stop.
Once the block is loaded, the lathe selects from an array of cutting tools. The ceramic tip can move at 20,000 rotations per minute, over 300 revolutions a second, carving out an intricate 3D sculpture. The friction is so intense, it has to be constantly sprayed with coolant.
We end up with this same part, shiny, brand new, all made in-house at Williams.
Well, the modern Formula One cars are much more advanced relative to 30 years ago. Williams is now a company of about 500 employees. In our first year, I think we had 8.
Patrick Head is Williams' Director of Engineering and co-owner. In 1977, Sir Frank Williams founded the team and immediately invited his old acquaintance on board.
He brought very solid, very organised engineering principles to the business of designing safe but competitive racing cars, and that's exactly what the company needed.
Well, I was impressed with Frank's passion and enthusiasm for racing, so I looked after the engineering and operational side while Frank looked after raising the money.
Remarkably, in 1979, after only 2 years in operation, Williams won their first Grand Prix at their home track of Silverstone.
It couldn't have been a better venue, that is for sure. It was a great day, and I think it was a popular win, and it was very satisfying.
From that first win in Silverstone in 1979, I certainly developed a very strong intolerance of not winning.
The win began a lasting era of success which catapulted Williams into Formula One legend. Renowned for their inspired engineering and iron will to win, Frank and Patrick produced a succession of victorious cars.
I think it's unacceptable for a team, if it has the tools, to go to a Grand Prix without turning up there with the intention of finishing first and second. That's what you go there for.
7 Drivers' Championships and 9 Constructors' Championships, making them one of the most successful teams in Formula One history. The modern Williams team are dedicated to keeping the winning tradition alive. One department in particular is working overtime. Jason Somerville is the new head of aerodynamics.
We're continually looking to improve the aerodynamic efficiency of the car. The difference between a fast and a slow car can often be attributed to the aerodynamics.
Every part of an F1 car's bodywork is aerodynamically shaped. A streamlined car cuts through the air better. But F1 aerodynamics also need to produce downforce. Downforce is the effect of air pushing the car onto the track. It's vitally important in Formula One. The cars are so fast that without downforce, they would be virtually undrivable. But if you can get the aerodynamic setup right, the wheels hug the road and the car grips well in the corners, that equals speed on track. The front wing is particularly important. It is essentially the reverse of an aeroplane wing. Instead of giving lift, a Formula One wing forces the car downwards.
The front wing has a big effect on the flow further down the car. And when it's balanced with the rear wing and with the floor of the car, we end up with a package which ultimately will go around corners a lot faster.
At top speed, the car's aerodynamic downforce enables a cornering force of 3.5 times its own weight, which means in theory, an F1 car could drive on a road upside down. Early Wednesday morning. Jason's junior designers have called him to an urgent meeting. They've spent weeks working on an innovative new front wing design, and it's looking good in computer testing.
Well, we've got, as you can see, very significant gain on the prospective F12 front wing. It will give us a greater mass flow into the inboard portion of the end plate, which is something we've been looking to develop all season. It looks to be a really good step for us in that region.
Okay, I think we should take this to the tunnel and get some wind tunnel results.
Jason believes the designers are onto something, but he needs more than computer theory. This is the wind tunnel. The wind tunnel is one of the most prestigious and effective facilities at Williams, allowing the team to get real physical data on aerodynamic performance. It's the envy of many teams on the grid. To save on time and materials, the test model of the car is made to 60% scale. Specialist model makers produce perfect downsized replicas of new aerodynamic parts. As the rolling road powers up and the wind speeds over the model, a guide arm feeds information to Jason and the technicians. They can tell how hard the car is pulling towards the track.
So we've got a good improvement in downforce. Well, if we have a good day in the wind tunnel, we typically find of the order of 1/10 of a second of lap time for the average Grand Prix. So that would be a good day for us. So, okay, so we've got improved performance across the range, okay.
The new front wing is providing improved downforce. Jason now knows he's got something.
Well, the wind tunnel results look very good. From here, I think we're going to go and chat with the chief designer and try and get this wing made.
The team are out for pit stop practice. A pit stop can make or break a race. One slip means several places lost on track. In F1, the crew are selected from amongst the race team mechanics. They are not full-time specialists. They have to keep on top of their skills in between their other work.
On the race team, when they do a pit stop, there's 27 people needed to make a car leave in 3 or 4 seconds. This comes from practice and everyone knowing exactly what they have to do within that pit stop.
To make the stops as fast as possible, 3 mechanics are assigned to each wheel. These 3 and the entire pit crew need to be perfectly choreographed. The race team manager is on the stopwatch and keeping an eye on every individual. A good stop should take under 4 seconds.
Very conscious of the pressure. We've all made the odd mistake. Most of the time we practice so much that it becomes second nature.
The sun goes down at the Williams factory. The night shift keeps pushing towards the deadline. In the Williams boardroom, the search for new revenue hits an important stage. The specialist Williams Hybrid Power Department have developed a Formula One technology which might have commercial potential.
The technology showed real promise in testing in the Formula One car. Then we realized that it has these great applications outside of Formula One.
It's a kinetic energy recovery system. Kinetic Energy Recovery System, or KERS, stores the energy wasted during braking and converts it into drive power. Whilst most F1 teams have a traditional battery, Williams have an alternative mechanical system. When the driver brakes, frictional energy is converted into electricity, which sets a magnetized internal wheel spinning at very high speed. The driver can then press a button and draw the energy from the flywheel to get an extra boost of drive power. The board are impressed with the innovative technology. The flywheel is incredibly efficient.
We're delighted with this flywheel technology. We've all seen the limitations that chemical batteries have, and coming up with this flywheel is great because it shows that there is an alternative that is much more effective, it's smaller, it's lighter, it's cheaper, it has a much lower environmental footprint.
It is extremely exciting doing what we're doing. We're working on a green energy technology.
It's potentially a game changer. Williams believe this is the commercial opportunity they've been looking for. They commit to developing the flywheel.
So we are continuing to invest quite large sums of money in the company because we believe that it's a great technology that is going to have application elsewhere.
Now, with significant investment on the line, Williams need the hybrid technology to sell successfully.
It's important financially for Williams if we've got an additional source of income coming from Williams Hybrid Power.
It's a gamble that could either help the team or prove a costly mistake. Williams F1 driver, Venezuelan Pastor Maldonado. Pastor is a former GP2 champion, a Formula One rookie.
To be a Formula One driver from Williams is a dream, completely a dream for me. Be behind of the steering wheel and to feel the power, to feel all the technology. The feeling is amazing. For sure in this moment I'm living a dream. The feeling with the adrenaline is so high. The adrenaline is taking the control of all your sense. The car feels improving race by race, test by test. You know, Formula One and Williams is always improving.
Pastor Maldonado races alongside F1 veteran Rubens Barrichello. Pastor's rookie seat is a good way for the team to initiate a talented new driver. Williams have assigned him his own Spanish-speaking race engineer, Chevy Pojola.
After each run, Pastor is giving us the information on what he feels, so we compare what he says with what we see.
They work together closely to optimize the blend between the car and driver. Pastor's feedback to Chevy about the feel of the car is one of the best ways for the team to identify areas for improvement. To help make that happen, the Williams Mega Factory has developed one of the most advanced racing simulators in the world.
The simulator we've got here at Williams is one of the best we've got in Formula One. This is definitely much more advanced than any computer game.
All the tracks on the world circuit are laser scanned in 3D. Every detail, down to a minor bump or curve, is fed into the system. Pastor is in for a day of simulator testing. He's trying out street circuits and night events that he's never raced at before.
As a rookie driver, the simulator is really essential to learn everything and to get more confident with the engineers, the way to work, the way to explain what the problems in the car.
If he feels that it's better or worse, and we can see that on the data as well, and from that just take decisions and conclusions just to move forward.
And even in turn 10 on entry, the feeling was okay to carry more minimum speed. But as soon as I touched the throttle, the car was too light. And then...
Try again?
Okay.
The simulator team can even test out new parts. They program in the wind tunnel results from the new front wing design. Instant upgrade in place, Pastor takes the tweaked up car for a spin.
With new parts, what we do is we test it first here, and if it works, if we see that there is potential, then we consider making it.
In the control room, Chevy has the use of complete performance feedback. He can see exactly how Pastor is driving and if the car has improved.
To
feel any difference riding the curves between one and the other?
No, no big difference.
Okay.
There is less on the steers generally. The new aero package feel fantastic. I've got more downforce.
The new front wing's improvement in the simulator is clear. It's a valuable positive for Head of Aerodynamics Jason Somerville as he sits down to a make-or-break meeting. Jason has to convince senior management that the new design is good enough to be made.
And we've seen some quite interesting gains pretty much across the map. I think the combination of about 6 or so changes around the simple geometry changes is giving us quite a good improvement.
It's a tough call. The new front wing could improve performance, but it's never guaranteed. And it will take time, money, and man-hours to produce.
There's some new components underneath. So I know that does add a bit of extra time to the process.
Yeah.
But I think we do need that change.
And we have enough time for Singapore?
I think so.
Yep. Okay.
The positives are too strong to ignore. Jason gets the green light. But there are now only 2 days to get it finished. Thursday. Making the front wing is in the hands of Tim Newton and the production team.
You can feel that the excitement that the new designs that are coming through are going to make a difference.
Producing new aerodynamics works an interlocking web of machines, departments and craftsman skills. Getting the front wing made in time will push the Williams mega factory to its limits.
Yeah, it could go right down to the wire. It's just about trying to make sure all the different areas are working together so that we get all the parts delivered at the right time.
Composites and autoclaves. The 5-axis automatic milling machine. To start the process, the shape of the front wing must be carved out on pattern board. The cutter only takes away a paper-thin layer with each sweep, ensuring the final shape is totally accurate. Pattern board is then taken to the carbon fibre composites room. Here they use the board to produce a mould. The mould is effectively a negative image of the final shape. In composites, an automated cutter scores out a series of patterns from a carbon fibre sheet. This is the pattern pack for a section of the new front wing. To create the part, a technician lays the shapes one on top of the other inside the mould. Each sheet has a grain. By changing the angle, sheet by sheet, the technician can make the part stronger. It's an excruciatingly complex procedure that requires total concentration. To make the carbon fibre hug the mould and take the shape, they are placed inside a vacuum bag. When the air is removed, the sheet layers are sucked flush onto the surface. It's ready to be cooked. Carbon fibre is made into strong, stiff parts by being slow cooked in large pressure chambers called autoclaves. The steel doors are 10 centimetres thick. All the parts of the front wing are now ready. There are 45 separate carbon pieces.
Okay, so now we've got to the dry fit stage. The front wing is like a complicated jigsaw puzzle. There's lots of different bits that slot together. And the wing is now being prepared for bonding.
The wing has to be bonded, allowed to dry, cleaned and checked before it can be released. It's one of several parts still in production. Getting everything finished will go down to the wire. As the factory pushes on, there's great news from Williams Hybrid Power. The team's investment has paid off big time. Porsche have bought into the Kerr's flywheel.
It's fantastic that we have Porsche as a customer within Williams Hybrid Power. They've come through as the first customer for this technology. They're a great brand to be associated with. It's so important for Williams Hybrid Power to have such a prestigious company as its first major customer.
Porsche are running the Kerr's system in their endurance race car, and it's performing well on track. As a result, Porsche also roll out the flywheel in the new 918 RSR. It could soon be part of selected production vehicles as well.
The fact that we're putting our technology into their racing car is a great vindication of our strategy of taking F1 technologies and applying them elsewhere.
Williams Hybrid Power is set to be an important player in providing Kerr's outside F1.
We have the makings for a great story, the contribution of Formula One to the outside world.
The new income and exposure is a huge boost for Williams. With extra finance in place, the team can focus on the business of racing. Friday, deadline day. The whole race bay team are in at sunrise. The cars have to be built up and then packed away for air freight.
The stuff has to leave here at 6 o'clock in the morning. This being Formula One and everything else, everyone works to all the deadlines. So if we have a problem with something or something like that, we could be here till 6. It's looking quite grim that that's going to happen.
The cars can only be built in a very specific order. Step by step, it grows out from the central chassis. Because numerous parts are still being repaired or fabricated around the factory, the engineers in Race Bay are often forced to wait for deliveries.
You're always waiting for one more piece of the jigsaw, so it's a bit of a waiting game.
A carbon fibre suspension wishbone has just come through ready to be fitted to the car. But the new gear change manifold isn't ready yet. It still needs to go through extreme stress testing. The power of a Formula One car will expose even a microscopic weakness, and a failure on track could ruin an entire race. The manifold is hooked up to a powered test rig. The rig produces the same output as an F1 engine. It hits nearly 290 kilometers per hour and slams through the gear changes, mimicking a full throttle lap on track. The newly fabricated part passes. Now the team can bolt the gearbox to the engine. In Formula One, the engine and gearbox are structurally integral pieces. They hold the rear wheels to the chassis. At full power, an F1 engine will use 450 litres of air a second. A driver can go through 8 of them in a season. A steering wheel has been rebuilt. Almost all an F1 driver's controls are squeezed onto the wheel. The gears, the clutch, the Kerr's boost. There's even a button for the drinks bottle. When the driver presses it, water is piped into his mouth through his helmet. As the day passes into the afternoon, the cars are really taking shape. But there's a problem that threatens to derail the whole schedule.
We're waiting on floors, so once we get the floors, we'll be done, but it seems to be grinding to a halt at the minute.
But it means the team need to wait for multiple parts before the car is ready to be shipped.
Until we get a floor, that pallet can't be done. It's just a waiting game, really, and we are waiting for floors.
To make sure none of the equipment or parts are damaged in transit, everything is packed in a very particular order. If something isn't finished, then nothing else can be packed away. On their last night before they're away from home for weeks, the team are looking at a very late finish. One part has arrived just in time. The new front wing. It's come into the sticker shop. Every sponsor's badge has to be perfectly placed.
It's important that they are quite smooth so it doesn't affect the aerodynamics of the car.
To save on weight, the stickers are specially produced to be as thin as possible. The front wing is finally complete. From design, wind tunnel, to composites, to race bay, this new part has travelled through every corridor of the Williams F1 mega factory. Every mind and machine focused on the 1/10 of a second improved performance. Only in the incredible world of Formula One. At last, the fifth and final floor arrives in race bay. It's the last piece in the jigsaw. The Williams FW33 can be prepared and boxed up for the 10,000-kilometre trip to Southeast Asia. The team are packed up and ready to go. It's a massive relief for the whole team. They'll have a final night at home as they prepare to head out for weeks on the road. For today, the mega factory has done its work.
It's good. It's always a good sign to see it go. Let's hope we've not forgotten anything. And we'll know Tuesday when we unpack it all.
As the lights go out on a successful week in race bay, the future looks bright for Williams Formula One. The new revenue from hybrid power will allow them to stay competitive and push on for honours in the years ahead. A huge boost for Williams' true heart, F1 racing.
We're building the new Williams on a very strong foundation, the pinnacle of motorsport that is Formula One.
But I know it'll give Frank and me a great deal of pleasure to see Williams return to winning position. Why aim for being fourth or third? Why not aim for being first?
Thanks to their unique mega factory and all the people that work within it, the legend of Williams Formula One will live on.
Brand new Mega Factories is back next Thursday at 9, right here on National Geographic Channel. Stay tuned for the latest from Drugs Inc.